Welcome, Benny. Welcome, Larissa. First, second, third. Hey, Erica. Hey, with 4 Ys. Katrin, you caught my sly switch there. Morning, Katrin. Morning, Samuel. If you don't think, what don't you think so? Holy, I'm getting Teams messages like crazy. Morning, Teddy. Morning, Lucas. Morning, Ruth. Morning, Maddie. Let's pour that juicy coffee here. All right, we're ripping. Morning, SJ. Yo, Jared. Hey, Yuli. Morning, Sadie. Ben. Life-threatening. Alrighty. Oh yeah, this wasn't working for me yesterday, so I have to try this again. Let's see. Do you guys have a section called Chapter 7? You do not, so let's do that. Shopping. Morning, Kathleen. No, Kathleen, it's pizza on your pineapple. Think of just like a slice of pepperoni. It's laid on top of this. Not just like a sliced pineapple either. It's just like the full thing. Using a pineapple as a plate. I believe this is going to send to y'all briefly here. But it might just take a minute, so we'll just talk and I'll do attendance while that's doing that. Sorry, last night it was like telling me that my OneNote didn't exist. And I was like, that's not a thing. It does exist. I know it does. Something failed. Okay. We'll get to that. Just for one person's though. Let me try that. Copy. Sorry. We're just syncing here. So, attendance then. Edsby. Okay. All right, so I saw Jared, I saw Sam, saw Teddy, no Crystal, Yulia I saw, Kathleen I saw, Katrin I saw, Maddie I saw, SJ I saw, Said I saw, Zion normally rolls in around now, Ruth I'm pretty sure, yep. Owen would be a no for Owen. Benny's here. Larissa's here. Lucas is here. Erica is here. She was third. And I'm pretty sure I saw Kendra. I feel like I saw Kendra. Heard from Kendra? No, not yet. Okay. Bingo. All right. I've been sent a meme or something. Teacher, that's perfect. I didn't think a picture of that would actually exist. That's funny. All right, team. So we are moving on to chapter 7 here, which is pretty crazy. We've been flying. Like, I'm only in like chapter 5 with my grade 11s, and nearing the end, but still, like, they're like a little bit further behind. So that's good for you guys. It's almost May, right? Like May, obviously is the month. May is the month before June. Okay, sorry, Zion's here. Anyways, school ends in June, so we really only have that like month stretch here to do that. So typically our chapters last, a couple weeks, so we're going to end perfectly on time, which is good because not a lot of grade 9 classes across Ontario are going to have like everything they need to know for next year. So that's pretty good, and it might give us more time at the end to come back and like dabble in some solving again to make sure we're really locked, because I also want like some of those really, really important things that you guys are going to go on to do again. We'll probably like just remind ourselves of lines, remind ourselves of the solving, things like that are like absolutely necessary for you to succeed in the next grade. But anyway, sorry, let me just fix my attendance. I don't think so, Benny. I don't think we need to extend the school year. There's no need. You guys have been going every day, right? Every day. So I don't think there's any need to extend the school year, buddy. Not for you guys, at least. We won't need to. You guys are going to be right on time. You guys are killing this math class. Doing good. Again, I don't want to say one way or the other, Benny, but like for our class, we wouldn't need to. No, I think if a public school needed to, but I doubt us. Kendra, no. Crystal did show, and Zion showed as well. So good. Awesome. Awesome. So if Owen or Kendra shows up, let me know. Actually, I'll just make them fix themselves later on, so that'll be fine. I still don't see. Do you guys see in your OneNotes chapter 7 somewhere in there? Oh, Owen's now here. Okay. Dang. I've closed everything down. Okay, because I'm not seeing chapter 7, but it'd be sweet if you guys had chapter 7. Owen is here. All right. What is happening? Where is my chat? There it is. All right. Yeah, lots of people have it. Perfect. Pineapple and pizza is great. No, Owen, it's pizza on pineapple. I actually got to show you the message Katrin sent me. It's pretty funny. It's like this massive slab of pineapple with like these little chunks of pizza on top of it. Okay, so we are finally not dealing with lines anymore. How exciting is that? Now, I guess we're doing geometry, which is like shapes, and shapes are made of lines, but you don't have to do y equals mx plus b anymore, right? So, hallelujah, life's good. I'm sure some of you are pretty excited for that. Even though this last unit wasn't too crazy, you did have to figure that out. Yeah, geometry, Benny. So like shapes, angles, things like that. What did you think? Did I lie to you? I lied to you? I might have. Yeah, at the very least, no y equals mx plus b. We didn't have to do that much last unit, so all is good. But yeah, we definitely didn't have to do too much. All right, so Zion's here. We're all good. Life's good. Let's skedaddle. So for this unit, I'm not seeing it in your guys, but I guess if you guys all say you have it, we should be good. We are looking at today. This whole unit is on like angles and triangles and things like that, but also angles inside and outside of shapes and looking for patterns in shapes. And so we're gonna do that. Today we're gonna talk about like angles inside shapes, and I'm pretty sure you guys have done a couple shapes, what all the angles add up to inside a shape in grade 8, but I'm not going to assume too much from the different groups that we have, just based on some things we've done before. So what I need from you is, could you open up this note? And we'll go here. I believe so. Tomorrow is our Wednesday class. I'm going to give you some time to practice things and meet with some people one-on-one if they need it. So we'll follow the pattern of supposedly students need a break on Wednesday. So we'll stick with that. I'll give you some work to do if you'd like it, but you don't have to get up at 8 kind of thing. So we'll start this. I'll give you some packages to work through, but yeah, we'll continue with the trend of if you need help, you come to me. I'm available at my computer the whole day, but give Wednesdays a bit of a break. So if we look at a rectangle, so we're just going to go through shapes today. Okay, our goal is to be able to, I could tell you guys how many, I guess, does anyone know? Let me just ask this first of all, because we're gonna find out here. In a triangle, what do all the angles add up to inside a triangle? Does anyone know that? Do you guys kind of know that? I feel like you've done some angle rules before, but I'm not totally sure, so I need your help. Awesome. So Teddy's seen that. Have other people seen that, or is that like, what the heck? Mm-hmm. Good, good, good. Hat, pie, something theory. Owen, never heard of that before. Anyways, so if we look at a rectangle then, and we use no, Lucas, I can teach you about pi if you want. That's more of like a, like you can learn about pi and what it is as a number, but in order to actually like start to use that regularly in class, that's not till like grade 11. Oh, Pythagorean theorem. We do learn that this year, or you guys have already learned that, but yeah, Pythagorean theorem. Yeah, but pi is radians, so we're going to talk about that. It's just like another way of measuring things. Right now, you guys talk about degrees, so when you hear pi, that's like another way of measuring an angle. If this one in here, if I said that this is a right angle, how many degrees is that angle? Oh, you guys can't see my note yet. Sorry. Let's change that. No green screen. Bingo. So, sorry. That little angle in there is a right angle. I haven't wrote anything yet, by the way. I was just kind of talking. So, this little angle in here, how many degrees is that? Yeah, Larissa says that's 90 degrees, right? So, if that's 90 degrees, they're all 90 degrees, right? The measurement of each interior angle is 90 degrees here. It's like what happens when you've got a square or a perfect rectangle like that, right? So what's the sum of all interior angles of a rectangle or square? Well, there's 4 90s, right? It'd be 90 plus 90 is 180, plus 90 is 270, plus your other 90, yeah, you'd get 360. Perfect. So there's one really cool program. I don't know if you guys want to jump on this for a second here, but if you go to the top here and you click this link, geogebra.org/geometry. So if you click that, I'm just going to bring this sucker down. What you can do is you can draw shapes and you can measure angles. It's really cool. It's just like going to allow us to draw and measure things in class without having to, have rulers and protractors in front of us. So if we look here, you can make, like these are your basic tools, and if you click more, there's a lot more tools in here for measuring and circles and things like that. But right now, let's just all draw. It does not have to be a rectangle, just any 4-sided shape. So if you click polygon, then all you got to do is you click once, it'll make A, and then it's like, okay, where do you want your next point? I'll just click here. And then, any shape, 1, 2, 3, 4-sided shape, right? So any 4-sided shape. I'm going to give you guys a minute to draw that 4-sided shape and be done with it. It will end and it'll let your mouse free when you've clicked and finished. Okay? Give me a newt or a thumbs up in chat. Larissa, it's at the top of the note, but I can also, I guess, paste it in chat. So let me know when you guys have a 4-sided shape, a quadrilateral that would be called, right? Quad being 4 sides. Give me a newt or a got it, thumbs up, something like that. Benny's got her, Larissa's got it. Maddie's got it. Okay, so here's what your next step would be. We're trying to prove that even though, we haven't got these things at 90 degrees, and again, maybe you guys already know this part, we're going to do more. I'm just teaching you how to use the program in something easy right now, okay? So, let's just get the money. Sam, no biking, eh? That's how you let me know you're done. No biking. So even if the shape changes from the angles of 90, 90, 90, 90, will it still be like that? Maybe you guys already know this, but we're just going to... Oh, sorry. Where do I want to be? I want to be over here in my GeoGebra. So what we need to do is I want you to scroll down. Hopefully you've hit all of the... Oh, let me get off the newt thing. Sorry. Shut up, Pengu. Okay, so I need you to scroll down to where it says measure. Okay? Measure, and I want you to measure the angle. Okay? So when you hit measure angle, so you had to click more first, right? So there was the basic tools. I clicked more. Then I scroll down to measure the angle. And then what you're going to do is if you want to measure angle A, you don't just click A. What you do is you call an angle by 3 points because it's the angle between 3 points. So if I want to measure angle A, really I need to measure angle DAB or DAB. So you first click D, then A, then B, and it'll tell you what the angle measure is right there. Oh, whoa. I think I just found a cheat code. That's awesome. Oh, all right. Just click and drag. Hit angle. I didn't know you could do that. That's awesome. Yeah, if you just have the angle and you're just like on this shape and you just like, oh, actually, you don't even have to click and drag. Just click the inside. That's amazing. I didn't know you could do that. Yeah, thanks, Owen. Sorry, I'm clearly an idiot. I didn't know you could do that. All right, so then move your little angles just where you can read them. This is me back up to the move tool. Just move them where you can read them. And what's really cool about GeoGebra is even if I move this point in here, you can see that it adjusts the angles, right? We could get it back to where it would be 90, 90, 90 or whatever it would be. But in here, this gives us something pretty sweet, right? We can also just click the middle, clearly. We can add up these again. So if I decide to add all these ones up, right? So if I take my calculator out and we do our 102.4. Maybe you guys can add up yours as well. 102.4 plus 106 plus 73.6. I'm thinking this is probably not going to be perfect. Oh, it will be actually. Plus 78 equals, hey, 360. All right, now mess with it again. Make it crazy. I don't know. Something like that. Let's try it again. So clear. Mine is 43.5 plus 139.8 plus, I can't see, 152.2 plus 24.6. It's not going to be perfect. That's sad. The problem is this program, it rounds decimals. It only gives you one decimal place, and that's the problem. So anyways, just you get the point, right? They all add up to 360. Doesn't have to be a perfect square. Doesn't have to be a perfect rectangle. You probably already maybe knew that. I'm not sure. But basically, any quadrilateral, which is a four-sided shape, has angles. So quadrilateral, four-sided shape. Also, all of the angles add up to 360 degrees. And those two right here, those are just little examples. So that way, you know, if you guys couldn't run this program, if it was blocked, you have those there or something like that. Okay, here's the other thing that you can do, and we're going to use this strategy to figure out how many degrees are inside any shape. It doesn't have to be a quadrilateral. Like how many degrees are inside a five-sided shape or a six-sided shape. And so here's the other strategy. I'm going to get rid of those angle measurements. I'm just going to hit delete on all of them. If you guys took your quadrilateral, basically what you could do is you can take your line segment. So a segment is something, so there's options up here. I don't know if you guys are still following me here. But a segment ends, right? A segment, you just go from here to here. Whereas a line, like we know, y equals mx plus b, lines go forever. So segments are just like from here to here, but lines go forever. Sorry, I just got to respond to one Teams message real quick. Where's my mouse? It's freaking out. All right. So if we create a segment, what are you talking about? Between the two corners, you can see that actually, like this quadrilateral, right, is made up of two triangles. And you guys told me that each triangle, if we remember here, oh, dang, that didn't work out how I wanted to, that each triangle added up to 180 degrees, right? So we'd have 180 degrees plus 180 degrees. That makes 360. So two triangles together there would make 360. So that's another strategy that we're going to use. Both of them come up to giving us the idea that we've got any quadrilateral is 360 degrees. So let's go back to this. Basically, right, since the sum of all interior angles of a triangle is, let's just write our note in here, even though we kind of just talked ourselves through this, 180, right? All of the angles inside there are 180 together. That means if we have two triangles, the sum of both of these together in our quadrilateral is 360 degrees. Okay. So let's get to some different shapes. Maybe some ones you guys haven't seen before, I'm hoping. Woo. All right, so thanks, Benny. It is the barnacle goose. It's like a snowbird. It has some information on the bottom about the barnacle goose. Early naturalists unable to comprehend the baffling... Anyways, I can't read it because I don't want to spill my coffee. All right. Homies, what I need you to do is I want you to draw in this thing. I want you to go back to GeoGebra. I want you to delete everything. Okay? How I did that is I went Control-A, delete. Control-A selects everything. Control plus A selects everything, and then press delete. So what I want you to do right now is I want you to draw a pentagon. Pentagon means 5 sides. So 1, 2, 3, 4, 5, bingo. Any predictions? Does anyone know how many degrees actually add up into a pentagon? $540, nice. Okay, so let's see. As we go through here, we just measure all of our angles again. Right? If I go measure, angle, and we look at all of those. Now I'm going to have to maybe move my angles a little bit. Yeah, that's exactly right, Larry. 0.4 plus 130.5 plus 91.8 plus 105.9. These sound like radio stations. Plus 106.3. 3 is 539.9. So yeah, like 540. Again, they're rounded. Okay, so hopefully you're able to do that as well. And your pentagon, which is different than mine, it doesn't have to look exactly like mine, but your pentagon has angles that add up also to 540 degrees. So go back down here to your OneNote, and the sum of all your interior angles is 540 degrees. That's awesome. What I want us to do now is see how many triangles we can fit inside. Okay, they have to go fully across and they don't overlap. Normally you line these things up on vertices as well. So when I say how many triangles we're fitting in here, I'm going to go back to this. I'm going to just delete my angles. And I'm going to make two lines that connect vertices, but they don't overlap. So I can't go from here to here. I guess I have to go from here to here. So now looking at a triangle, right? How many triangles fit inside? Remember our quadrilateral? Oops, sorry. Let me delete that. Yeah. If you remember our quadrilateral 1, 2, 3, 4-sided shape, right? We could fit two triangles inside of that. And we knew that that was 180 and 180 was 360. Here we can fit 1, 2, 3 triangles inside of that. So 180 plus 180 plus 180 is 540. So let's just go back and get that in here. I might draw myself a little crappy shape here. Or if you guys want, if you've already got it, you don't even need to draw it, right? Zoom in on this guy. And just hit that F11 in your computer. It's a print screen button, right? F11 to print screen. So you can hit bingo. I think there's like an export feature up here, like export a picture. Anyways, I don't even see it there, but it doesn't matter. Oopsies. I'm making more dots than I planned. So then here, and I might just paste that little picture. It's going to be massive. It won't be. It'll be the opposite of little. Shoot. Yeah, mine I have dual screen. So anyways, for you guys, I'd paste the picture in there. Since I got the dual screen, I think I'd need to use the snippet tool to do a better job with that. But anyways, how many triangles do you have inside the Pentagon? I have 3. So the sum of all the interior angles of the triangles would be 540 degrees. What is true about this sum of your answer in part B? Well, they are the same. I'm going to write same wall. So all of the sides inside a pentagon are hexagon. Same deal. I'd look down at my GeoGebra. I'm just going to delete everything again. If you guys want to join me in that, Control A, delete. I think I really screwed that thing up. So again, a hexagon is a 6-sided shape. So you're going to do, that's 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. And again, I would just say, just so we can check the original way first, let's add all these up. Right, so while you guys are doing that, I will just move my angles so we can see them better. Oopsies. And then I take my calculator and let's do it. So 115.8 plus 103, again, these sound like radio stations, plus 116.3 plus 145.9 plus 119.2 plus, did I get all the way to 118 yet? No, 118.9 is Teddy right. 720, yeah, awesome. So 720, right? Big brain time, baby. So all of them added up to 720. I'm just going to pause there for a second just in case anyone wanted to check my work there on that, but you might be getting a pattern here. So 720, oopsies, that's a highlighter. Okay, 720 degrees. It says how many triangles can I draw inside the hexagon? Same idea. You don't want them to cross and you want to use the vertices. So Vertices are the points. Let's look here then. I'm going to delete all these angles again. So how many triangles can I draw? Well, if I make my line segment, here, I go from A to E, E to B, B to D, I see I get 1, 2, 3, 4 triangles, right? 4 triangles. Perfect, right? Perfect. 1, 2, 3, 4. Yeah, Kendra, you found the pattern, right? There's a gap of 180. Owen's found the pattern as well. He's added 180 to 720, right, to figure out how many sides a 7-sided shape would have, or what's the angles in a 7-sided shape, right? You get 900 here. So let's just go back. There was 1, 2, 3, 4 triangles. Sorry, getting ahead of myself here. How many triangles did you fit inside a hexagon? You fit 4. So what is the sum of the interior angles? Well, if we wanted to know, right, if we didn't, you could go 4 times 180, which is 720, right? There's 4 triangles, all with 180 degrees in them. So anyways, it'd be 4 times 180. And then, so I don't even know, we'll just write same again. That's what's true. I thought it was Indy 500 too, but maybe there's also an Indy 900. I'm not going to argue with them. I don't know anything about cars. Okay, let's just do this one quick. I won't do the big add up time. You guys seem like you already know the 900 degrees here, but let's just see if that's true. If we can get prediction would be, right? Back here, we had 2 triangles for a 4-sided shape. Then for a 5-sided shape, we had 3 triangles. Oops, whoa. 6-sided shape, we had 4 triangles. 7-sided shape, you'd assume that we'd have 5 triangles. Let's see if that's true. So I'm going to delete everything again. Join me if you'd like with this. 7-sided shape. That's 1, 2, 3, 4, 5, 6, 7 sides. Again, I could do the little... I think there's probably a way that you can add numbers together quickly in this program. I just can't remember. It's been a while. But anyways, how many triangles can I make? Well, here is 1, 2, 3. Remember, we predicted 5. And I see 5, right? 1, 2, 3, 4, 5 triangles. Oh, Indy 900 is a skateboard move. Oh man, I miss Tony Hawk Pro Skater games. I wish there was like good new skateboarder game. I don't think there is. There's something like Skate, but I don't know if it's good or not. I never played any of those. Anyways, there is 5 triangles. And so that would be 5 times 180. And what is true about the sum of your answers in part B? Well, they're the same. Again, I don't know why I even include that crap. Let's just go same, lol. Okay, so do you guys have the pattern? Oh, sorry, let me let you get this down. I think we all do. Let's just record that pattern below, and then we'll be able to basically be done with this crap. Skate is good. It's a masterpiece, hey? If you guys, there's like some like skateboard game for the phone, but I don't think it's like a tech deck game. I don't know. I don't understand how you'd possibly play it. Like, but anyways, I just remember the Tony Hawk Pro Skater. You go around, you had to like do these like insane like grinds to get places, and you just spray paint stuff. I don't know. They were always pretty fun. Okay. I forget the name of the one I liked. It was like Underground or Wasteland or something like that. Micah had it, eh? Cool. So we looked at the pattern here, right? We said that basically a triangle, how many triangles is in a 3-sided shape? Well, a 3-sided shape is a triangle, so there's 1 triangle, right? In a 4-sided shape, so like a quadrilateral, we said there was 2. 5-sided shape, we said there was 3. 6 was 4, 7 was 5. What do you notice about the side lengths and the number of triangles that fit in it? Can somebody tell me what the pattern between side lengths and number of triangles that fit in it is? Sam, you can get Roller Coaster Tycoon free in a cereal box. Those were classic. -2. Yes, thank you, Sam. In my brain, Sam, when you just wrote -2, I thought you were messing with me about leaving the camera again. When I think -2 or -1, it makes me think you guys are always giving me the -1. 1 times 180. Right? This is 2 times 180. 3 times 180 was your 540. 4 times 180 was your 720. That's as far as we got. Oh, wait, no, we didn't. 5 times 180 was 900. 6 times 180, oh my gosh, equals 1080. And then a 20-sided shape, it would have 18 triangles, right? 18 triangles in it. Basically, those weren't the same. That would be 18 times 180, and I don't know, 10 times, oh, thanks, Kendra. Wow, 3,240. 3,240. Okay, so before we move on, is there any questions about that? It's still a game, guys. Okay, so for any n-sided shape, it would be n minus 2, right? N sides, it's n minus 2. So you'd have n minus 2 times 180. Sure, Maddie. Okay. So, does anyone remember what the word irregular means? Irregular. We're almost done, guys. We literally have this and this. We have 2 more examples. Like it's going to be less than 5 minutes. I would recommend actually getting your coffee afterwards, but whatever. You don't have to ask me to leave. Irregular. Does anyone remember what that would possibly mean? So, irregular shape. Oh, sorry, Eric, I lost the live stream. An irregular shape is a shape where where not all side lengths and angles are the same. And as Ben said, no one wants to play with them. So, wow, this is a delightful apple. In this case, if we're looking at that, sorry, that's a bit ugly. A regular polygon would mean that all side lengths and angles are equal. Be careful not to spell angels. So, if I want to figure something out in here, okay, the best way of doing this is to see how many triangles fit in, right? It's the best way of doing this sucker here. So if I look Oopsies. Go there. There. See triangle there. And there, right? So I've got 1, 2, 3, 4, 5 triangles. Perfect. 5 times 180 is going to equal, what was our 900 degrees. Just quickly, you can draw the triangles in there and then multiply like that. Okay, so here's a slightly different question. They give us no shape or no picture, but they say all of the angles together, they add up to 2,340. How many sides does it have? So that's a bit interesting, right? What I would do here is for me, I would say, you've got me mistaken, sir. Okay, anyways. As soon as you said sir, I thought he was talking to me. If I wanted to know, like a regular polygon, it means they all have the same side. So I want to know basically how many sides does this shape have, whatever. So what I would do is I want to know how many triangles, which is 180 degrees, fit inside 2,340. So to do that math, that would be 2,340 divided by 180. And Kendra tells me that is 15. So that means 15 triangles fit inside. But then remember, as Kendra's saying, as well as SJ is saying, and basically we need to add another 2, right? Because 15 triangles fit in, but remember, if it had, for instance, 18 triangles, it was actually a 20-sided shape. If it had 6, it was an 8-sided shape. So you're kind of going backwards. So that means that it is, therefore, a 15 plus 2, which equals 17-sided shape. Cool? All right, I'm just going to show you. We're not actually going to do... Oh, did I mess up? Is 2,340 divided by 180 13 or 15? I don't know. I didn't do it. Oh, awkward. It's 13. Oh, no problem. We just start getting ahead of ourselves. So 13 plus 2 is 15. Oopsies. Good job, guys. No worries. Thank you, thank you. There was a 15 in there somewhere, right? We just we got ahead of ourselves. All's good. Perfect. So, we're not going to do that thing at the bottom. Here's what we're going to do instead. I have sent you 2 pages. I've sent you this one here called Interior Angles, and then I've sent you this one here called Sum of Interior Angles. So there's 2 of them. Wait, so I was right at the beginning. I think so. Doesn't matter. Okay, so this one here, this is a pretty easy page. Oops, shoot, I've sent it to you with one of them done, but that's okay. I'll explain this one here. I was going to explain one to you anyways. So if you have a regular 17gon, which means a 17-sided shape. Polygon means many sides here, but regular 17-sided shape. What I would do to figure this question out is I want to know what the sum of the interior angles would be. So we take your 17, right? And how many triangles is going to fit inside? It'll be 17 minus 2. That'd be 15 triangles. and we'd multiply that by 180, right? So 15 times 180. Wait, did we literally just do that? No, we didn't. There was a different one. We did a 15. Yeah, now I'm all confused. But so if we do 15 times, I'll just do it in here. AD, that's equal to 2,700. Okay, so all of the angles on this 17-sided shape add up to 2,700, but then it wants to know what each angle would be. So there was 15 triangles, but 17 sides. Really just think it's a 17-sided shape. So if I was able to draw a 17-sided shape, which I'm not going to be able to, 5, 6, 7, 8, 9, 10, just pretend there's 17 sides, okay? Each of the angles would be the exact same. And so what we do is, if I want to know what each angle is worth, I would take that 2,700 for the total angles, divide them by 17 to know what each angle is worth. There's 17 angles, right? In a quadrilateral, if I had a regular quadrilateral, oh, dang it, like the one at the top, let's just go back up to the top. If I had a regular quadrilateral, like back up here, right? Regular because, you know, all the angles are the same. Now the side length should be the same too. But if I know they all add up to 360 and I divide them by, there's 1, 2, 3, 4 angles, that tells me each is 90. But here, if we're going to divide it by 17, again, we'd take your 2,700, divide it by 17. We're going to get equals to 158.82. So each angle is 158.82. Delightful coffee. So all I want you to do is there's some answers at the bottom there for each of these. You could see for this one here, there's an answer key below, but try and do these 6 questions on your own. I guess there's only 5 now, so that should be pretty easy. And then these here, again, there's only like 6 questions. These ones, you have to think about, okay, what should, in this shape here, what should 1, 2, 3, 4, a 5-sided shape add up to, right? Well, we know it's 540. And so if they all add up to 540, how could I get X? Well, this would be what's left over, right? So you take 540, subtract 105, subtract 118, subtract 75, subtract 130, and see what's left over. And so that'll give you your X. So I'll leave that to you guys. You can hit me up if you have any questions. You have 30 minutes, so it should be more than enough time to finish those 11 questions. All right, guys. Thanks for watching. I will see you guys soon. Message me. Remember, tomorrow I can give you guys some more to work on if you need it, but I'm sure I might have a couple questions, so I'll meet with you guys individually if you need it. Have an awesome day. Much love. Keep her going.